By we've talked about most of this vocabulary, except for the last two. The idea of a periodic function is simply one that repeats itself. If you, I'm going to tie it back to unit circle. The basic point, though, is if you go all the way around circle once and then start going around again, you're going to repeat these coordinates. You're going to run through this again and again every time you go around the circle. And those coordinates are for the functions. And so that's we'll explain that more later. Right now, draw this, write this down. What we're going to do is get our definitions for the trig functions on the unit circle that we'll use. It comes from SOHCAHTOA, but we don't use that anymore. We'll use these letters, X, Y, and R. Okay? Now, I drew this nice, simple picture with a first quadrant angle, but the reality is your angle could be in any quadrant. So you won't always see the triangle using theta. But we're going to get our definitions from this because it's easy. Sine is so, opposite of picture, what's opposite? Y over R. That's your definition you want to memorize. Sine is Y over R. Okay? Cosine is adjacent over hypotenuse for R. Tangent doesn't use the hypotenuse at all. What is tangent? Good. And by the way, tangent is special. When you do calculus, you talk about slope of the tangent line. And actually, I want you to associate tangent with slope. Is delta y over delta x? Tangent's y over x. So there's a close relationship there. Okay? That's all I'm going to say for now. You got to get tangent right. Y over x. Now, the other three are just reciprocals. So this is just r over y. X over y. In terms of memorizing these, I really want you to memorize these first and foremost. And if you know these, and you just know these reciprocals, then you're good. So you should know about it. I'm sure everyone knows. Sine, reciprocal sine is called cosecant. And then reciprocal sine, cosine and secant. I want to mention again, by the way, you have two relationships going on here. You have sine and cosine, and you have secant and cosecant. But the co-function relationship is a different relationship. I'm not going to explain yet. But like tangent, cotangent, the cotangent is also reciprocal to tangent. But in other cases, it's not. The reciprocal line is not called cosecant. That's the co-function of secant. And so you have the reciprocal relationship, then you also have the co-function relationship. About later. So write this down, and I'm going to write down all those directions. They're a bit wordy, but you needed, be able to digest that. While people are talking this, can someone tell me which quadrant that point would be in? Right. So once you get done copying the problem, draw that point. Put a point in the second quadrant. Angle we're talking about then is the second quadrant angle. Okay? One more question before we get started. Is this point a point on the... And before you answer, let me just say this. If I go back to the unit circle, there's a lot of points you're supposed to know on the unit circle. I say a lot. It's only 16, actually. How many circles is... how many points is a circle composed of? Infinite number. Okay? And so there's a lot of points in this unit circle you're never going to see. So for instance, and don't write this down, these are the point in the unit circle. They are. These, how do you know these are not on the unit circle? Because these numbers are bigger than 1, so it can't possibly be 1, right? So it's not about whether you recognize the numbers, it's whether can the radius be 1, and it's a definite no in this case. So what I'm saying is, if you're in the unit circle, that's simplified. If you're not, you just have to use definitions. So it asks for the six trig functions. We're going to find sine, cosine, tangent first, using the definitions. Sine is y over r, and y is 3. Any guess what r is? It's 5. By the way, I forgot something. So back here, we had the definitions for the 6 trig functions. You're all supposed to know that in this picture, x squared plus y squared is r squared, obviously. But remember that. You have the 6 functions, but you also have Pythagorean theorems that you can apply to this picture. And we need to do that right now in our example. Right. So here, x is negative 4, so negative 4 squared plus 3 squared equals r squared. By the way, a lot of people, they'll write this down wrong. They'll still say it's 16, but technically, if you put it without the parentheses, you get a negative. If you want to square it, you must put parentheses around it. And so just know that, like I said, otherwise the calculator will give you the wrong answer if you don't show it right. And sure enough, you get 4 to 25 is 5. You already just know it's a 3, 4, 5 right triangle. Okay? But that means sine is 3 over 5. What's the definition for cosine? So what's that answer? Yeah. And I'm going to work this, like with the negative sign in front of the fraction bar. If you put negative 4 over 5 like this, it's okay. If you flip that and left like this, you can't get full credit. Your denominator should never be negative. So I'm saying we prefer to see it like on the fraction bar. A tangent y over x is the one that does not involve the hypotenuse. Over x. So, yeah, exactly. But I said tangents always y over x. Sine and cosine, they're always y over r. Okay, let me pause here. I'll get back to that. I'll get back to that. Let me just finish this example. There's a point I want to make. So we'll wait. Let's go back and do the trig. Cosecant is just reciprocal sine, so it's 5/3. Secant is reciprocal cosine, it's negative 5/4, and then cotangent. And so that's what it's saying. You know your basic three first, and then just know which ones are reciprocal with those. So we're done. Now we'll do this again, one more time, with just a little bit less nice numbers. Yeah? Oh, yeah, we actually, that's a good point, I forgot to mention that. First of all, and that's the difficulty here, is like here, in the original drawing, I formed a triangle, right? You don't see a triangle here. You could actually form a triangle like this, and I could get these definitions using that triangle. But I talk about how you get to these answers, the relationships. For now, me that while we got the definitions from this basic nice picture, and you want to use this picture to get your definitions, they work no matter what angle is drawn. And so, saying here, you're not going to see the triangle really very easily. So I don't want to try to get there right now. It's a very good question. All right, write just the new coordinates down. And we're only going to do the basic three. Okay, so the same thing, we'll be doing less because it's harder. Which quadrant? So draw it as such. And by the way, the x value is smaller, so I'm going to try to draw it roughly to scale. So there's our point in the fourth quadrant. Theta is, of course, an angle. And I was going to mention, we actually don't find the angle in either of these examples. It doesn't ask for the angle, so don't worry about that. And sine is y over r still. Y is negative 6, but r we don't know. So we do Pythagorean theorem again. So 9 and 36 is what? So this is not as nice. You get square root of 45, which simplifies to what? Yes. And let me explain how to... If the number is relatively small like this, you should just be able to say, oh, it's just 9 times 5, and square root of 9 is 3. That's the quickest way to simplify this. Or Or if you're not, don't think of it, or if you're just uglier numbers, then break it down to 4. If you divide, you get 5 by 3 again, you get 5, you get 1, which tells you can rewrite the radical like this, but this is just 3. So you get 3 radicals. Okay? Now, so that's our radius. Now we can do our definition. It was r, so put the r there. 3 radical 5 goes there. You can cancel. You get negative 2 over square root of 5 when you cancel a 3. What's the final answer? Good. Because you need to multiply top and bottom of square root of 5. And this is the result. Square root of 5 times square root of 5 is 5. And the numerator ends up like that. And we do cosine x over r. X is 3. R is still 3 radical 5. This is a little easier. You get 1 over square root of 5, which is, square root of 5 over 5. And then tangent is really easy on this one. X, which is negative 6 over 3, which is, yeah. And if it asks for if it asks for all 6, we'd have to have a reciprocal of these, which we've done before, actually. We're going to move on. All right? Okay. The next thing was triangles. We talked about that. That's just, 90, 180, 270, 360, pi over 2, pi, 3 pi over 2, 2 pi. I'm not going to give you time to write that down. Down. And just, define the exact value of cosine of pi. Now listen, this is what I alluded to before. Look, cosine of pi. You could try to use the overall, like the general definition. Except, you don't need to. You don't want to. What I'm getting at is, if you look at your circle, this thing's called the inner circle, R is. So, if I'm on the unit circle, cosine is x over 1. Write this down. On the unit circle. So, on the unit circle, cosine is just the x. And only on the unit circle. Okay, really? It's not getting better. So if I look in the unit circle, what is the x value at pi? -1. So cosine of -1. And sine of pi, if it asks for it, would be the 0. That is easy. So if you took the calculator and typed in cosine of pi, if you're in radian mode, you get -1. By the way, that means cosine of 180 degrees is the same thing, isn't it? Because pi radians is equivalent to 180 degrees. So the same question, just with the different units. Either way, the answer is -1. Now, so on your unit circle, take your unit circle. I want you to record this here as well. Basically, what I want you to write down somewhere, maybe in the top, is that the x-coordinate is your value for cosine. Just write this down somewhere off in the margin somewhere. That's what's supposed to be true. On the unit circle, the x value represents the value for cosine, the y value represents the value for sine. And then, if I go to, like right here, you can say that means that number, that x value, is the value for cosine of 30 degrees. And the 1/2 is the value for sine of 30 degrees. That's what you're supposed to know. So if you type in the calculator cosine of 30 degrees, you like 0.8, which is what that equals, approximately. And then if you do sine of 30 degrees, it would spit out 1/2, 0.5. So that's the point in unit circle. Cosine, or y over r and x over r in general, but they're just x and y. So you can just look up your values for cosine and sine right here. So what is cosine of 210 degrees? Cosine is negative square root of 3 over 2. Sine of 210 degrees, negative 1/2. Okay? What's cosine of 270? Sine? Tangent? What is tangent? What's the definition of tangent? So you do y over x, which is negative 1 over 0, which is undefined. You can't do that. And actually, we'll do that. We're about to do that here. Go away. So here, next one. Just where'd it go? There it is. Hold on. I lost the whole page. That's wonderful. So just write this down. Cotangent of 7 pi over 2. That's the example. It's supposed to be there. Same directions. Find the exact value for this. There's a couple things going on here. One is our angle is bigger than 2 pi. And so one thing you want to do is get your angles down between 0 and 2 pi, or between 0 and 360. And so for that, what we're going to do is subtract. Write that down. We're basically doing coterminal angles again. Subtracting 2 pi, or in other words, we're subtracting how many halves? 2 pi equals how many halves? Well, 7 halves minus 4 halves is 3 halves. Which 3 halves pi is due south. So that's 3 pi over 2. 7 pi over 2, you go all the way around, and then around to face due south. So the coterminal angle. So they point to the same direction. So the coordinates are the same. Cotangent is x over y, because it's shift cotangent. So it's 0 over negative 1, which is, just for the record, you might write this down, like as a related example. If it is tangent of the same angle, it's 1 over x, so it's negative 1 over 0. But you can't do that. Instead, it's undefined. And just for the record, if you try to put 0 as an answer here, it fails because 0 times 0 is not negative 1. Whereas up here, 0 times negative 1 works. 0 times negative 1 is 0, right? Be careful. Don't get those backwards. So listen, if you're asked to evaluate a trig function, that's all you have to do is look it up in the unit circle. And if it's sine or cosine, you just write down the numbers you see. If it's tangent or cotangent, you have to do x over y or y over x to find out the. Okay? So let's get down. Write down. What I want you to do is write down the definition for a reference angle, and then draw at least one of these pictures. If you have time to draw more than one picture, great. But at least in the picture, it has the red angle drawn in it. And like I said, try to draw at least one of these pictures. You'll see, in every case, the red angle is your reference angle. They don't even have arrows there, which is good because it's like an angle in geometry where you have no sense of direction. It's not like with normal angle, you're either rotating counterclockwise from due east or due east. You have a positive or negative angle. But the reference angle is just the amount of rotation between that terminal ray and the x-axis, the closest part of the x-axis. This book uses like theta is original, which we always do, but then they call it theta prime for the reference angle. That's a good symbol. I don't think that's universal. It's just a symbol. But that's a thing. And once again, if I go back, okay, write this down. Let's say I said cosine or negative 150 degrees. And we're going to use a reference to answer. Now, I want to understand, you have at least two ways you can figure out the answer to this. As long as you figure out the answer, I'm happy. But reference angles ultimately will be the fastest way to get this done. Okay, so that's what you want to strive for. So I'm saying, if you're on a quiz and all you can think to do is what it is and write down the coordinate, that's fine. Without even thinking of reference angles. And so let's get the answer that way first. Don't write anything down. Just think about this. First of all, before I show you the unit circle, can someone tell me which quadrant this angle points into? Third, because look, positive 150 would take you into the second quadrant, but it's in the third quadrant. Okay? Now, look at this. So I'm saying what you could do is realize if you go backwards 150 degrees, it's going to point you in that direction. It's going to have, it's along this line. It has a reference angle way. But the point is, if you just know negative 150 points in that, if I want cosine, then it's that number. There, you're done. The answer is negative square root of 3 over 2. But we're not going to do it that way. We're going to use reference angles. So we said, and draw the angle on your paper. Draw negative 1. It looks like that. Like we said, the reference angle is 30 degrees, because 150 is 30 away from 180, right? It's 30 degrees away from horizontal. That means the answer is cosine of the reference angle. Or maybe the opposite of that. I'm saying the reference angle is going to give you the right value, the right number. What you have to worry about is it the right sign? And look at this. Well, first of all, if we're in the third quadrant, right? So it must be true that cosine of our angle is the opposite of cosine of the reference angle. And what's cosine of 30? Square root of 3 over 2. So the answer here is actually negative square root of 3 over 2. So what I'm saying is, if you can figure out the reference angle, and you know which quadrant you're in, you can just figure out the answer. To put it another way, look at this. If you can just memorize the first quadrant, you get this part down pat. Then, like that is cosine of 30. Square root of 3 over 2, you just know that. Sine of 30, 1/2. What's sine of 45 degrees? Square root of 2 over 2. So now, what is cosine of 135 degrees? Well, you're in the second quadrant with a reference angle of 45 degrees. It must be a negative square root of 2 over 2. And so, we're going to keep working on this idea of using reference angles. But it's just one way to think about the answer. But ultimately, it's the fastest way. Okay? So if you can figure, however you can figure out the answer to this is fine. But that's what you want to work towards. Here, write this down. We kind of already did this. Let's see that. Actually, I'm sorry. We already did that one. Write this one instead. Which quadrant? Yeah. It's more than half pi, less than 1 pi. It's actually in the middle of the second quadrant. That's your angle. What's the reference angle? Just a 4th pi, yeah. Because once again, half circles pi radians. If you do 1 minus 3/4, you get a 4th. And so, the angle is pi over 4, first of all. So if you want to call it, if this is theta, then this is theta prime. You can use that notation for the reference angle. And so let's actually do an example. So let's write this down. If I ask you what's cosine of 3 pi over 4, then you have to decide, is it equal to or the opposite of cosine of the reference angle? And I'm going to do both, sine and cosine. And let's do this quickly because there's one more thing I want to get on paper before you finish. So which of these will actually be equal? Which opposite? Look, if you go left instead of right, isn't your x value the opposite? In the second quadrant, cosine would be the opposite of the original. Whereas sine is positive in either case, isn't it? That's what I'm saying. That's your two possibilities. That's the whole point of reference angles. They give you the answer. In both cases, it's square root of 2 over 2. Because at pi over 4, it's square root of 2 over 2. If you're in the middle of the quadrant, it's easy. But here it's negative because it's positive. I mean, the opposite. And this one's positive because it's the same. One thing that'll help with this, because I said there's one more thing I want you to write down. Hold on.